Welcome, everybody. So I'm Nigel. Tom, do you want to say a couple of words?
Thanks, Nigel. Thanks, Fred. So hey, everyone, I'm Tom Phelan. I am currently a fellow at HPE, Hewlett Packard Enterprise. Prior to that, I worked at a startup company known as Blue Data. Blue Data, we'll be talking a little bit about what the technology they've worked on, which is to run artificial intelligence, machine learning, deep learning applications on containers within your enterprise in a secure environment. I've had 30 years in the industry, worked for companies like VMware, Silicon Graphics, have a long history in operating systems, containerization, virtualization, and storage. Really happy here to talk this morning, at least for my morning. That's 8 o'clock here on the Pacific coast of the United States, about Kubernetes and all the various attributes of that. So thanks, Nigel.
Sweet. Okay, nice one, Tom. So I'm excited. So we're going through intros right now. I will pop the agenda up in just a second so you know what we're doing. But the idea is we're going to talk about 4 things to do with Kubernetes and loosely related to machine learning and things as well, okay? But we're going to take a break halfway through to answer questions, and then hopefully we'll have time at the end for a full-on Q&A. You got anything you want to say right now, Tom?
Yeah, this is great. Thank you for answering the poll. I like this combination of audiences. So we have 50%. They're like, we're just learning Kubernetes. That's fantastic. But then we have 5% that are actually using it in production. Wow, that's really good. So we have a great audience. We can learn from each other as we go through this. And as Nigel points out, we'll make it as interactive as possible.
Here. So we'll talk about Kubernetes. What is it and why have we got it? Then after we do that, we'll get into okay, well, how do we actually install it? Then we'll take a break. We'll start talking about stateful applications with Kubernetes after that, and then security. And at the end, we will have a wide open Q&A. So let's rock and roll. Kubernetes, what and why? Now, I'm going to start the ball rolling here and then hand over to Tom, because nobody wants to listen to me talk for super long, okay? But Kubernetes, what is it and why have we got it? So for me, I like to roll the clock back to when Amazon Web Services first came out. And we may even have people on the call, and raise your hand if this is you, okay, that are kind of so young that Amazon Web Services was around before you started your tech career, okay? That's all right if that's you. But Amazon Web Services came along and really disrupted the industry. And they started, for want of a better term, eating everybody else's lunch. And the wider industry needed a response or a retaliation, if you want, to Amazon Web Services, like a way to hit back and stop losing customers and win back customers. And the first thing that we tried was OpenStack. And OpenStack was a great effort at going toe-to-toe on a feature-by-feature basis against AWS. Ultimately, it didn't turn out to be the right approach, but loads of great people and great companies were involved, and we actually learned a ton from the OpenStack experience. But at the same time as Amazon Web Services and OpenStack going on, containers were starting to become a thing from Docker. And containers and Docker were building all of this momentum. And we started deploying applications in containers and got, as you'd probably expect, we got container sprawl, and we needed some help managing our containerized applications. Now, Docker came along with a product called Docker Swarm to help us with that. But at around about the same time, Google, who had been running containers for years internally, so like Google Search and Gmail and GFS and things like that, were all running on containers in the background at really huge scale. So Google had these internal technologies that they were managing containers with, inside the company. And they decided to tell you what, we'll take what we've learned internally and we'll open source a brand new product. We'll call it Kubernetes. There's a story behind it, but we won't go there now. But we'll release Kubernetes to help everybody manage this container sprawl. So along came Kubernetes. There's a lot of things going on here, don't get me wrong, but Amazon Web Services disrupted everything. Kubernetes came along to help us manage containers. But what Kubernetes also did was it abstracted the infrastructure below it. So you might hear people talk about Kubernetes as the cloud operating system, right? So the same as Linux and Windows abstracts server hardware, Kubernetes abstracts, let's just call it cloud infrastructure at the moment. So it came along as the operating system for the cloud, and it abstracted Amazon Web Services. So, of course, everybody that needed a response to Amazon Web Services loved it. So kind of accidentally, Kubernetes came along and said, look, if everybody else adopts it, we've got an easy off-ramp from Amazon Web Services and an easy on-ramp to everybody else's cloud, or even to running Kubernetes on premises. So just to summarize, Kubernetes is two things. Right? So we have it. Why do we have it? Well, to help us manage containers, okay, but also to abstract the value of or the sticky stuff of infrastructure platforms like Amazon Web Services. Why has it got a strong future? Because everybody needs it, like the industry needs it, and users need it. So because the industry needs it, everyone in the industry needs it, it's got a bright future. That means that end users can feel safe to adopt it, and it will help them manage all of their new containerized applications, and it will help them move workloads easily between clouds. So that's my effort at what is Kubernetes and why do we have it. But Tom, do you have any thoughts on that as well? And I'll take a look at some questions that might be coming in.
It's a great synopsis, Nigel. Thank you very much. Nigel covered all the key points. I want to drill down a little bit and just kind of flesh this out for us. So, as Nigel said, the world started out with virtual machines. If you recall, EC2 for AWS, that was the first platform where we could run our applications on the public cloud, and the public cloud would provide flexibility, convenience, reliability, security. People really liked that. But then, as Nigel said, we evolved. Virtual machines were a little bit heavyweight. You really didn't need an entire operating system image to run your application. So there was work being done in the open source community, and we had things like Docker Swarm. You remember the Docker runtime? Docker Swarm was the first type of container orchestrator. That's the general term for what Kubernetes does. You also might remember a company called Mesosphere. They tried to push another type of container orchestrator known as Mesos, but didn't really catch on. Just really didn't catch. It took a company like Google with the resources and open source drive of Google to come up with Kubernetes. When I talk to people about Kubernetes, I say it's an API. That's all you really care about. It's an API. So you as an application developer can develop your application and deploy it anywhere if you have the Kubernetes tooling. So if you know how to use kubectl and you use a few other commands, that's all you need to know. And then you can deploy your containerized application on EKS, on GKE, on Red Hat OpenShift, on VMware Tanzu, anywhere. So any on-premise or public cloud solution will take and deploy your containerized application if you use the Kubernetes protocol. That's what makes it so powerful. It's this open source de facto standard that the Kubernetes community has put together. So that's from the developer side. And I'd also say, as Nigel points out, there's true value in the infrastructure. Even though you as an application developer are protected from the infrastructure of Kubernetes, as you should be, if you're more of an IT bent, or you're managing the Kubernetes cluster for your application or for your enterprise, you have things like CNI, the Container Network Interface, things like CSI, Container Storage Interface, and then your container runtimes, and even things like custom resource definitions. Those abstraction levels make it very easy for different network technologies and topologies to be plugged in, different storage topologies to be plugged in. And that's how companies can provide you value without you having to change your Kubernetes APIs. You don't have to write your code specifically to any vendor, but they can still surface you their value adds. And one great thing is there's a language called Go. You're probably familiar, at least in passing. All of Kubernetes is written in Go, and there's various levels of that. You can get as deep as you want, things called custom resource definitions, which are units of Go code that you can write if you have deep knowledge of Kubernetes and your application. You don't have to write them if you don't want to, but if you really need fine control, you can do that. So what Kubernetes gives us, it gives us this API for the developers to use and application writers, and then it gives a whole collection of APIs for the infrastructure, security team, network team, storage teams to use. And together they provide a very flexible, powerful, and open container orchestration for us running our applications in containers. I could go on for this forever, but I'll turn it back to Nigel in hopes of keeping this down to a reasonable time.
Tom, you picked a great time. I've got a mouthful of munchies. So we've done the what and why. Let's talk about where and how. So I've got some ideas on this. I don't know if you want to go first on this one, Tom, so that I don't maybe steal anything that you want to say. I guess now we've talked about why we've got Kubernetes and what it is, it's probably a good idea to say what are some ways to maybe install and get it, yeah?
Sure, fantastic. Yeah, and I look at this as a couple of different vectors when we talk about how do you install Kubernetes, where do you want to run it. Okay, typically there's two things that people talk about. They say, hey, should I install my Kubernetes containers on bare metal, or should I install them on virtual machines? And let me put that aside, but that's one big question we talk about when we talk about Kubernetes installation. And then we said, hey, what about on-premise versus public cloud? So those two vectors together are what we use for a discussion of how to install and manage Kubernetes. Let's talk about the first one. It's probably no real secret. While containers are lightweight, they do share an operating image. What that means is that what's called the attack plane is larger than what it is for a virtual machine. With the virtual machine, you have a completely isolated operating system image. If your application running in that virtual machine does something crazy, does something malicious, it's probably not really going to hurt anybody else but the applications running in that image itself. With Kubernetes, since we're sharing, or not Kubernetes so much, but more containers, since containers share operating system resources, if you have a malicious or ill-behaved application running in one container, it could negatively impact the performance or security of another containerized application running on that same host. Okay, and so that's why some people say, okay, it's better to run containers in virtual machines because you have a unit of security isolation, you have a unit of quality assurance isolation. They're called like noisy neighbor. Noisy neighbor is typically the term you use when someone's taking up so much CPU resources that it's adversely impacting your performance. Now, Kubernetes environment or the Kubernetes open source community is working to address those, but I mean, it's an issue when you choose to deploy your Kubernetes clusters. Will you be having applications that need to be isolated from each other in terms of performance and security? And if you have that situation, then you might want to consider something like virtual machine isolation or another solution for protecting quality of service and security. And then just to wrap up that second vector, which is on-premise versus cloud. Well, cloud obviously has huge benefits with flexibility, ease of use, accessibility. You don't have to worry about installing it. You don't have to worry about patching it. That's someone else's problem. You just use it as a consumer, and that's great. But there's this concept of data gravity, and this is where we find most of the issues around on-premise versus cloud. If you have large existing data lakes, for example, you're training a machine learning model, based on this data set, and you need to probably locate the compute for that training. So your TensorFlow or Spark SQL, whatever you're using to train your model, you want to probably locate it relatively close to where your data is. Otherwise, your network and data charges will be substantial. So as you think about your needs, your application needs for you and your enterprise and your application, those are the vectors you need to think about. Nigel, I'll be back over to you to complete that out.
We've seen a trend in the industry where, initially, and it still is a little bit now, right? But Kubernetes was really hard to install, especially if you wanted to do like a production grade install where you had like high availability and high performance. So a lot of people were initially put off, and the cloud vendors saw an opportunity there to say, okay, I tell you what, let's go for a model where we, as your cloud supplier or your cloud vendor, we will build and manage your Kubernetes cluster for you. and release you to care about your applications, which is a great model, really, because a lot of businesses don't really want to be infrastructure and don't want to be Kubernetes businesses at the end of the day. They care about their apps and delivering to customers and what have you. So there was this huge wave of companies that were taking their first steps in Kubernetes using the hosted Kubernetes services, like of all of the major clouds: Azure Kubernetes Service, Google Kubernetes Engine, Elastic EC2 Kubernetes Engine, Kubernetes Service EKS, all of those, right? Because they made it easy for you to get a production grade Kubernetes cluster and run your apps on it. But, and a lot of people will know where I'm coming from here, over time, when you start consuming cloud services, you start to notice the costs racking up, maybe more than you initially thought. So then companies were starting to think, well, what if we do spin up some Kubernetes on premises and we manage it ourselves? And what had happened for a lot of people is, because they'd initially deployed to the cloud, started putting applications out there, they kind of not silently, but unintentionally upskilled in Kubernetes. So that they maybe went from like a 0 to a 3 or a 4. And from a 3 or a 4, it's much easier then to take the next step and start building your own Kubernetes clusters. So don't get me wrong, like the hosted Kubernetes services on all the public clouds are a great way to get started with Kubernetes. But as you progress, and I think especially in the enterprise, where you really need more control of your infrastructure and your applications, top to bottom, more and more people are starting to say, right, let's start deploying our own on-premises, or even building our own in a public or a hybrid cloud. So not taking a hosted service, but taking cloud instances and building your own Kubernetes on that. Gives you a bit more control, sometimes more control over cost and things as well. However, in order to do that, you really are starting then to look at your traditional enterprise partners. I'm not being a shill here, but HPE and all the different companies out there that have historically been great partners to the enterprise, you're looking to partner with them to get your support contracts, to get your, your professional services that will help you when you get stuck and things like that. So I really saw a model where 2019 was huge for hosted Kubernetes, 2020 as well, but as people gained expertise and experience, they started saying, well, the costs are high and we're a bit cleverer with this now. So maybe we'll start balancing our environment so that, yes, we might still have our hosted Kubernetes, but we run on premises where we build our own as well. And the beauty of it is, right, as long as you're not buying into all of the proprietary cloud services from all the different cloud vendors, you can easily move applications from one Kubernetes cluster to another, whether that's from the cloud to on-prem or from on-prem to the cloud. Super simple from that perspective. So I don't know about you, Tom, unless you have anything further to say on that, it might be time to take a break and have a look at some questions. But if you've got anything else you want to say, by all means, let's do that first.
I would just say, just wrap up on the, because I think you brought up a really key issue there, right, at the very end, Nigel, and that is, hey, we as containerized developers, as application developers, we want to make sure that our applications can run anywhere. And as Nigel points out, it's not Kubernetes. Kubernetes provides us the common API. There's a common set of services like Istio for service mesh, Envoy, those sorts of things. Those are common in Kubernetes environments. However, there is a temptation with some of the public cloud providers to tie into their security framework, for example, or to take advantage of some proprietary or a unique feature of the public cloud. And that's where we get lock-in. And so when I'm always talking to customers who are saying, okay, should I deploy on a cloud? Should I deploy on premise? How should I architect my future? I always caution them, hey, make sure you think about the future. And if you are integrating your code with a service, while that service may be very, very helpful, you need to think about day two when you might need to migrate your application to another provider due to security reasons, due to cost reasons. We don't know about the future. But as Nigel points out, that's a key consideration when you are looking at your deployment of Kubernetes. Make sure you don't lock yourself in so that it's more expensive and time consuming to move later.
So I'm an independent here, right? So I feel like I'm allowed to say this. I really do feel like, and I don't blame them here, okay? All the clouds, of course, want you to consume more and more of their services. And one of the ways to do that is to get you to use all of their different cloud services. Instead of doing everything through Kubernetes, if you start doing a few things outside of Kubernetes using their proprietary services, it might be easy on day one, but you kind of get stuck there going forward. So try to avoid that as a pattern if you can. So on that, I'm going to just flip to the break section now. I've written down a couple of the questions that we've got here. So I've got 3 questions here. The third one about using storage classes on premises, we are going to talk about stateful data next. So I'm going to park that one because Tom and I might just cover that in the next section anyway. But unless Tom or Fred has seen different questions, I can answer a question on the Docker shim and the shared kernel model. Do you have anything you want to go with before that, Tom?
No, please go ahead with that. There's been a number of questions on security, so I think I'll speak a little bit about that after you go, Nigel.
Okay, and remember, we do have security as the last topic for everybody who's listening here. So we're going to touch some aspects later on anyway. So there was a couple of questions raised around Kubernetes dropping support for Docker or the Docker shim. So let me just paint the picture here, right? So a typical application workflow, and when I say workflow, I'm talking about from developing your application all the way through to running it in production, has looked something like this. And I'm going to be high level, right? Big picture stuff. You write your application in whatever code you like, whatever language, nobody cares, right? Well, you do, but whatever. Then typically you will use a tool to build that into a container image. There are loads of tools out there, but the most popular one at the moment is still Docker. So Docker will take your code and its dependencies and build it into an image, okay? Now, Docker builds it into something called an OCI image, an Open Containers Initiative image. It's an industry standard image. That's going to be key in a second, right? Then you go to run that, and you get Kubernetes to run it in production. Only Kubernetes, and I'm looking at my camera here, right? Kubernetes is a high-level tool up here, and it actually doesn't know how to start or stop or run containers. It orchestrates them, so it makes decisions like, which node should I run a container on? And if a node fails, where do I restart the failed containers on? It makes high-level decisions like that. It uses another tool at the lower level, go this way, to actually do the running of containers. Now, historically, it used Docker to run the containers. So Kubernetes up at the top, making all the high-level decisions, saying, right, Docker, run this container on this node for me. Docker on another node, run this container. Kubernetes in charge, Docker doing the low-level running of containers. And that was done as kind of like, because Docker had all the momentum, Docker was dead popular, Kubernetes was like, who do we get to run our containers? Might as well make it Docker, yeah? Then it decided, tell you what, we'll make this low-level container runtime layer pluggable. So you might hear something called the container runtime interface. It means that you can take Docker out and put a different container runtime in there. Importantly, as long as it runs OCI images, you're good. You can still use Docker to build your images. They're OCI images. You put a different container runtime in on Kubernetes. As long as it runs OCI images, you're in business. Now, what's happened is Kubernetes have said, we're going to get rid of Docker as the default container runtime, the default tool that we use to start containers. And the reason is it doesn't support this container runtime interface. It doesn't support the plugin layer. We've had to have a shim there to make it all work for years now. So Docker as a runtime will go away in a future release of Kubernetes. However, still using Docker to build your images, those images will still run on a Kubernetes cluster. Hope that makes sense. Now, I'm going to say, while we're talking about this container runtime interface layer, where we say you can put in your favorite container runtime and swap them out for different ones, different container runtimes have different like performance and security features. So most of them have the shared kernel model that Docker is kind of famous for. We've had some questions about shared kernel. So if your container runtime operates a shared kernel model, everything that you run on Kubernetes on that node will go with a shared kernel. But some container runtimes have a different model where they might spin up a virtual machine for every container. If that's the case, then it's no longer a shared kernel model. So asking the question whether or not Kubernetes has the same shared kernel model as Docker, the answer is, well, it depends what you're using to actually run your containers, because Kubernetes lets you plug in your favorite container runtime. Most of them, for sure, they still go with the shared kernel model, but not all of them do. So if you need to run containers and you need to use Kubernetes, but you can't go with a shared kernel model, there is a container runtime out there for you. Okay. You got anything, Tom?
No, that's great. There was a lot of good questions here. I think you've addressed most of them. I would just like to, there was a question about running multiple containers within a single pod. There was a great answer from the audience who came back. I just want to, because that's a really good question, specifically since we have, approximately 50% people who are more or less new to Kubernetes. Kubernetes is what's called, and Nigel brought this up, a cloud operating system. It is designed to run applications that are authored in what's called the cloud native architecture, which means they're written in microservices. A microservice is a completely stateless piece of code that can be restarted or horizontally scaled. And that just so you understand, that's different than typically the way we wrote code in the 80s and 90s and even the early 2000s, where you had complex, poorly defined interactions between threads of execution. And so you couldn't really restart a portion of an application without it having negative impact on the other services within that application. With microservices, we've installed a discipline in the way we write code, so that each unit of code has a different life cycle. It can be started, stopped, restarted, and so applications communicate via well understood APIs, typically like queues or something, so that they can restart. When we say multiple containers within a pod is a unit of deployment. A pod is a Kubernetes term. It has an IP address and a number of other artifacts associated with it. And it's a collection of containers. Each one of those containers can be restarted independently. They run an independent microservice. And I think as the responder on the chat responded, pods are deployed on a single worker. So we have a concept of a Kubernetes worker, which typically maps to a single physical host. And so a pod of containers is deployed as a single unit on a single Kubernetes worker. And typically multiple pods will be deployed on different workers to give us high availability for a particular cloud service application that we've written. So in a nutshell, I'm just trying to help on the education of Kubernetes for our audience. Nigel brought this up. This is about, and it addresses container runtime. Someone was asking about kata containers. Kata containers are different than Docker containers. And as Nigel pointed out, they have a virtual machine-y like concept associated with them. So they don't share as much of the resources as Docker containers. They also have this unique attribute where they don't change, they're static. So people tend to use kata containers when they do not want to be influenced by changes in software. So they want to bundle and pack a software stack, and they never ever want it to change. You typically see this when you're doing model training in areas where you need to have reproducibility. So if you're doing a medical research model, and 2 years from now, you want to be able to recreate that exact same model, you would use a kata container image to fully encapsulate all the software. With Docker, while it's more common, you have the ability to pull in different versions of software when the container is launched. So when it's instantiated. What that means is from instantiation to instantiation, you may have subtle differences in the code running in your container depending on how you have authored your container runtime file. so that the file itself, you could say, refer to this Python library and pull in the latest version. If you need something like that, you'd use a Docker container. If you don't want that, you'd use something like a Kata container. I know that's a lot of buzzwords, but just for those people who are interested in the difference between Kata and Docker, that would be one of the primary differences.
Magic. Appreciate that, Tom. Right, so let's crack on a little bit now, because we do want to try and leave some time for questions at the end. Big shout out to everybody as well who is helping to answer the questions in the chat. Massively appreciated there. So from a Stateful Apps and a Stateful Data perspective, I'm just going to sort of paint the picture of where Kubernetes is at the moment, then hand over to Tom for some further insights. So I really feel like when containers and Kubernetes and things came along, they followed the typical model of, doing the easy stuff first. We call it low-hanging fruit quite often, yeah? A little bit like VMware did. We did the stateless compute first. And kind of followed almost the VMware model. And it's pretty standard, right? Where once you sort of get good at the compute, you move on to do networking a bit. And then finally, you get around to persistent data and storage. And I think one of the reasons that tends to come last is, well, it's complex, but it's also super important. Like if you break storage or lose data, then you are in like a proper world of hurt. Whereas, no disrespect to any network engineers out there, but if you break the network, usually when it comes back up, everything finds itself and we're all good, right? You make mistakes with storage and you could be losing your job, and you could be losing customers, and even losing your entire business. Anyway, so Kubernetes, when it first came along, and containers, they just did the easy compute stuff. I reckon 2020, I know it was a bad year in a lot of ways, but it was a great year when it came to persisting data and storage in Kubernetes. So a lot of like the important low-level plumbing was completed in 2020. I think it was early 2020, the container storage interface, which is an industry standard specification for presenting external storage into orchestrators like Kubernetes, went 1.0, I think very early in 2020. And since then, it has matured, and industry partners have come along and they have bought into the whole model. So the idea of the container storage interface, or the CSI, is that it's a plugin layer that says, we'll take whatever external storage, and it can be cloud storage, it can be on-premises storage, and as long as the provider of that storage writes a CSI plugin, that storage can be exposed into Kubernetes and consumed by applications. 2020 was a huge year for that. We've also got objects in the Kubernetes API like stateful sets and things, which are designed to work with stateful workloads. So I feel like sort of state of the union on storage and persistent data with Kubernetes is that we're at a mature enough level where the low-level plumbing is done, and it is good enough and reliable enough for most production environments. What it really needs now is the wider ecosystem and the data management companies to come along and not only have their CSI plugins, but to expose their advanced features, data protection, replication, things like that, via the Kubernetes API. So I'll just wrap this up and hand over to Tom. But the idea is that the Kubernetes API is what everything's going to talk to. So instead of talking to whoever's storage system on the back end in their native sort of configuration, just talk to the Kubernetes API and say, right, I want a volume of, solid state volume that's replicated across a couple of data centers, and it gives me this many IOPS per gigabyte or whatever. You talk to the Kubernetes API in a standard Kubernetes API way, and then the plugins and the way that the storage vendors have extended the Kubernetes API does all of the hard work making that storage happen on the storage backends. So the idea is the vendors come and make their storage features and their data protection features and things like that look, smell, and feel like they are native Kubernetes objects. So we're at a point where the plumbing is done and it's reliable enough for production. It's now kind of hand over to the vendors and to the wider community and ecosystem to say, make it enterprise ready, bring the battle-tested storage arrays and make them consumable via applications in Kubernetes. So that's me, Tom. What are your thoughts around that?
Yeah, that's great, Nigel. Yeah, the whole CSI itself, hugely valuable to the developer community and the user community of Kubernetes. Just to add, and you did a fantastic job of it. It isolates the HA, the disaster recovery, the snapshotting. All that is isolated from the application. You don't have to build into your application now a snapshot and recovery model. If you're running it as a cloud native application on Kubernetes, you get those solutions built in. Huge value. Make it really streamline application deployment and creation. What I'd like to talk about now is beyond the CSI, beyond the CNI, which are the what I would call them the southbound interfaces for Kubernetes to enterprise quality networking or storage. Let's talk about applications that are not cloud native architected. So let's say we have an old application. I know every enterprise I've ever talked to has 1,000 J2EE applications that are written in Java. They've been running and they don't even know where the source code is. They don't know how to compile them. Everybody's retired that ever worked on those applications. How do I run those applications on modern Kubernetes infrastructure? So that's what I want to spend just a few moments on. Now, you can refactor them. So the customer or the company can pay to have a new set of engineers learn how those applications were put together, reauthor them in cloud native architecture. That is costly and time consuming, but some companies are doing that. Let's just say it's not worth it, or it's going to take too long for a company to do that. They want to take their existing J2EE application that's not microservices. How do you map that onto a pod? How do you break down your services that have strange, ill-defined interdependencies, run them in containers and deploy them on pods with Kubernetes? Here's where we have things like Helm charts, or you maybe have something like Kubeflow for pipelining. There's just a shameless plug. There is a new open source project called KubeDirector, which HP is one of the supporters of, and it helps author custom resource definitions, which, as we spoke about very early in this call today, is Go code that is crafted specifically to the running a particular application type on Kubernetes. What you'd have to do today typically is you'd have to author in Go your own CRD, and it would be specific to a type of application. So it would know that CRD code would know the strange interdependencies of your legacy application, and it would do the things that Kubernetes cannot do for you automatically. It's challenging to write those pieces of Go code because you have to have deep application knowledge as well as intimate knowledge of the Kubernetes API itself. With tools like KubeDirector, it takes a YAML file, basically a few hints, it will generate the CRD code for you. And so you can port many applications quickly onto Kubernetes. So when you're thinking about your needs of Kubernetes, what are you going to run on there? Are you going to run your legacy applications on there? How will you run them? You need to look at things like CRDs, Helm charts, KubeDirector, those sorts of tools to make sure that you can run your legacy applications on your new platform.
Cool. So I was just going to put some more minstrels in my mouth there. So it was a good time to stop. I'm going to move us on just because of time, Tom,
right.
to our last subject, which I have got for you to lead us in on from a security perspective. Yeah.
Yep. Thanks, Nigel. And this is one of these topics that's near and dear to my heart. Not just because it's in the news recently, but because it's important. It's important to everybody. It's important to everybody on this call that we do our part to make sure that the software we're writing and deploying for our customers is secure. And so, like I said, this could go on forever, but let's just keep it a few minutes. Let's just talk about security. When we talk about security, we have to begin much lower than containers. How do we trust our hardware? How do we trust our operating system running on the hardware? How do we trust our container runtime? and the Kubernetes worker and controller services themselves. You'll hear things about silicon root of trust. You'll hear about signing. You'll hear about supply chain attacks. This is where malicious software has been introduced into software at day zero. So before you've even installed the software at your premise or on your host, it's already been corrupted. So we have to build in supply chain confidence and then verification that after we've installed the software, no one or no agency has come in and modified it so that it does some activity that we are not aware of. So we can go on that, but I'll just leave that as as things to think about. There are plenty of webinars and talks about that in the future. Let's move up to Kubernetes. And so when we talk about Kubernetes, we talk about containerized runtimes. Obviously, everyone says, well, I have a scanner. I have a scanner which checks my code for CVEs. CVEs are what are called common vulnerability and exposures. Organization called MITRE does work to track these CVEs, assigns them a severity. And typically organizations say, oh, if it has a severity of 7 or greater, I'll make sure I patch it. And so I will be protected. And that's fantastic. That's all well and good, but that's table stakes today. Literally, that's table. If you're not doing that, you probably have malicious software running in your containers. Flat out. I can probably say that with great confidence. Even if you're doing that, you probably have people now exploiting lower severity CVEs. So CVEs with severity levels of 3 and 4 and 5. People are now targeting those because they know organizations don't normally address those low severity CVE incursions. So make sure you do that. And then even beyond that, beyond patching, we have to talk about zero-day attacks. Zero-day is when there is no publicly known exploit. So there's some code running in your organization that no one yet has seen the exploit from. And so you need to detect that. You need to make sure that you have telemetry information. You need to use tools like Falco and Jaeger to monitor the traffic, east-west traffic between your containers, and then north-south between your containers and external services. And so what I would say for best practices is make sure that you lock down and you have security policies, port security policies, network security policies for your systems. And then even after you define those, you have to look for drift. Drift is where people accidentally make changes that they don't fully appreciate the security impact of. So they may do something completely, what they feel is completely innocuous, but it opens up a great big hole in your security environment. So like I said, we only have a limited time today, but I just want to point out to you a number of different areas where you as an application writer or a Kubernetes manager have to really be aware, and it's a real problem. There are no more walled gardens. Boy, I wish we lived in 20 years ago where we could say if we had LDAP or Active Directory and we could just get through our walled garden, everything would be safe. But it's not anymore. So once we're even in that garden, we have to make sure that everything is secure. So Nigel, like you said earlier, no one wants to hear me talk for 10 minutes about security. So I'll turn it back to you.
I loved it, Tom. I don't know what you're talking about. It's good. Still admitting people with like a minute to go. Well, I mean, somebody can shut us down here on the HPE end if they need to, because I'll just keep talking all day. I just close out the security topic by saying that everything that you've trusted security-wise over the years, you still need to do and be on top of when it comes to containers and Kubernetes. The whole like layered approach to security, you still have to do all of that, protect your networks. Tom talked about CVEs and image scanning and stuff like that. I did just want to mention, just because it came up earlier around the shared kernel model, that if you have to go with a container runtime that operates in a shared kernel model, there are tools out there like SE Linux and AppArmor and SecComp and capability dropping and things like that that will kind of secure that model up. So like SecComp will filter the syscalls that a container can make to the shared kernel. And capability dropping will allow you to run as the root user, but then drop certain capabilities that the root user has. Now, these can be sometimes a little bit too complex. They're getting simpler, right? But sometimes I feel it's still a little bit too complex to use. But you can look at them and they can really shore up the security of a shared kernel model. Now, on that, I'm going to just go to open Q&A at the end. Whoops. Fred, if we have to shut this down, by all means, just shout me down. But I'm just going to thank everybody for...
Don't worry, we've got plenty of time. I mean, we've got around 10 minutes to go.
Magic.
And I'm not planning on shutting down the call at 6 sharp, don't worry. So if you go over, the more questions there are and the more that got answers, that's the better.
Need to give us some kind of shutdown time, otherwise we'll be going at this time tomorrow still.
Okay, I'll give you like 10 minutes, Matt.
No, it's cool. Yeah, we'll take 10 minutes.
All right.
So, no, I think Tom and I massively want to thank everybody for their input. I feel like it's been a really interactive session. We really hope it's been valuable to you. And thanks, especially to everybody that has posted questions and even to the people that are answering them. I have posted in the channel. I know that not everybody has Twitter and things like that. But if you post a picture of the things that you're eating on the Slack channel or onto Twitter, I've eaten, they're gone. It's empty. I'm going to be ill tonight. We will pick, or I'll pick my favorite, and we'll get you a free ebook. We'll go through the questions that we've had here as well, and we'll get some ebooks sorted out. We do have a poll that we've just opened up as well, and we'd massively appreciate it if you could fill in the questions on the poll. And we've got one person, three people. Okay, so people are starting to notice the poll now. So I'm going to move that across there. I'm going to scroll down some questions. Tom, if you've seen anything that you want to tackle, by all means, jump in straight away. If not, I'll find something.
There's a couple of things. I mean, while you're looking through there, Nigel, there's been a couple of questions about something called K3S. You might also hear something called Kube Edge, and there's a question right now. I think that someone asked, "Hey, what about running Kubernetes on edge nodes?" Edge nodes are, the definition is a bit fuzzy, but what we typically say is edge. It is a device, low power device that is connected over probably a relatively unreliable network. So something like a WAN rather than a LAN. Okay, and how can we use Kubernetes, or can we use Kubernetes to deploy applications on these edge nodes? And for this discussion, let's assume an edge node is something like an IoT device, a very small camera, for example, that's capturing data on a manufacturing floor, looking at bolts. And you want to run your AI model to say, hey, this bolt, which I'm now looking at now, meets specifications. Can I use Kubernetes to deploy my model inference out at that IoT camera? Okay, and then there are, so the community, Rancher has a tool called K3S, which is a stripped down version of Kubernetes. And there's also Huawei's been a major provider of another alternative called Kube Edge, which does something similar, but both of those still require a certain amount of compute and memory at the edge. And this is where I would love to have my knowledge increased. As Nigel pointed out in the very beginning, there may be work in the Kubernetes area that I'm not familiar with, but on an IoT device, today, I mean, a really low power IoT where you can't run K3S, you could do something where you could script and deploy just a Docker runtime and the container and have it then run your machine learning model inference at the edge. So I'm unaware at this point where if Kubernetes has a open source project where they're targeting extremely low functionality IoT devices. But I do believe that will come eventually. K3S and Kube Edge are excellent if you actually have a lower power computer at the edge, but if you have an IoT device, you're going to need something else. But it's a great question.
And on that topic, it's probably important to point out that Kubernetes runs pretty much anywhere these days. So there were questions about running it on Windows earlier. So of course it runs on Linux. You can run Kubernetes on Windows now, worker nodes in your cluster, Raspberry Pi. Of course, it doesn't really care whether you're on premises, whether you're in the cloud. There are loads of solutions for running sort of lab environments on your desktop and stuff like that. You literally can get Kubernetes anywhere these days. So I did see some questions around the CSI. So I'm just going to tackle that. Appreciate the 76 people who've responded to the final poll. I do see there's over 100 people still on the call. So if you haven't done the poll and you don't do the poll, I will hunt you down and make you pay. No, I'm just kidding. It would be great if you could fill it in. On the CSI, so there was a question around, can you leverage the CSI only if you are running Kubernetes in the cloud? And the answer is no. So you absolutely can leverage the CSI, and it lets you leverage cloud-based storage if you're running in the cloud. But if your Kubernetes cluster is running on premises and you have storage systems on premises that you love and trust, as long as they have a CSI plugin that you can run, and you run it usually as obviously as a set of pods on your Kubernetes cluster, that CSI plugin will allow the assets from that storage array, an HPE, Nimble, or a 3PAR or something like that, right? Just as an example, expose their resources into Kubernetes where applications can consume them. Bingo, works brilliantly. And there's another question around the HPE data fabric, which I am not an expert at, right? But saying, does the CSI do away with that? Now, the simple answer to that is it doesn't, okay? What it is it's an abstraction layer or a standard way to expose things like data fabric and 3PAR and whatever else and cloud storage into Kubernetes and have it consumed by applications. So the CSI is an enabler. It doesn't do away with backend storage technologies. It allows you to plug them in to your Kubernetes cluster. So see if we have any more questions. I mean, there may have been some way further up, but I'm not seeing any that are down towards the bottom of the chat now. So unless you see anything, Tom, I mean, I'd be happy enough just to thank everybody for their time today. It's been a bit of a blast, to be honest, though I have eaten far too much chocolate. Would have been better if I'd had the hot tamales. I'm feeling a bit sick now. Are you all? Do you think we're done then, Tom?
I think we're, unless there's someone wants to, and I know we have maybe 30 seconds or something left here in the scheduled time. I want to personally thank everyone for making this this webinar so enjoyable and informative, and especially a shout out to Nigel for his time and expertise on this for us. Yeah, I'm good. I think it's a wrap unless there's some final questions here.
No. So I've got a slide up here that just shows some upcoming events that we've got. I'm going to flip on to the final slide now as well. Just how to connect and keep in contact.
I can take over if you want, if you don't mind, Nigel. So go back one slide. I mean, the next session will actually be taking place next month, obviously. Could you go?
I'm trying to.
Oh, I'm sorry.
Yeah, there you go.
Okay, so the next mention then will take place at the end of March, okay, on the 31st. There'll be around data science unplugged, and the speaker will be an EMEA field CTO from HPE. The host will be Ellen Friedman, and obviously the registration link will be sent over to you on time, don't worry. And finally, if you want to get in touch with the HPE dev community, in the last slide, then there are several ways of achieving this. If you don't mind going to the next slide, Nigel. Please. Yeah. So the portal, the hpdev.io, the Slack channel where we actually post some munchies, hopefully. We have a dedicated monthly newsletter, and you can reach out to us on Slack, on mail, on Twitter, through the Yammer group. The session is obviously recorded and will be made available at a later time, along with hopefully all the questions. So I wrote down the question, and if some did not get answered, I'll probably come to Tom and Nigel to fill the response for me, and I'll send them over. Lastly, but not least, but not less important, the workshops on demand. So we have our Hack Shack Live. So it's a virtual Hack Shack where you can actually run some workshops. It's Jupyter notebooks based. So there were many talks about the CSI driver. We actually have one workshop that is dedicated to this. We're working on building a new one on Data Fabric 101. And there are several on Ezmeral and Kubernetes. I know that Didier did some work on the Kubernetes 101 as well. It will be made available in the forthcoming weeks or months in our Hack Shack. So stay tuned and have a look at this. With that being said, I will thank you, Nigel and Tom, for these very, 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 very interesting sessions. And all the feedbacks that I can see in the chat were very, very good. I mean, they really, everybody enjoyed it. And somehow it seems that the last poll that says 100% was good use of my time, technical level was absolutely right. So, and we'll recommend the Munch and Learn, yes, 100% too. So I think you did a pretty good job. And so I will thank you, and I will stop the session from now and leave everyone to his work or to his rest if they're in EMEA, I suppose. And thanks again, and have a good day. Bye-bye.